Hello everyone, myself Ans. Today we are going to solve the problem of UPSC Maths Optional Paper 1 question from topic multiple integrals. Here in the given question, evaluate the integral 0 to infinity and again 0 to infinity e की power minus x square plus y square dx dy and hence also show that 0 to infinity e to the power minus x square dx is equal to root pi upon 2. Let's solve the problem. Given integral is 0 to infinity and 0 to infinity e to the power minus of x square plus y square dx dy. Given integral, first convert into polar coordinates, that is x is equal to r cos theta and y is equal to r sin theta, that is x square plus y square is equal to r square and dx dy in place of r d theta dr putting. So the region of integration in the first quadrant, so r varies from 0 to infinity and theta varies from 0 to pi by 2. From here, that is 0 to pi by 2 and 0 to infinity, that is e to the power minus of x square y square in place of, that is r square minus of r square and dx dy in place of r d theta dr. We integrate with respect to r. First we let r square is equal to t, that is on differentiation 2r dr is equal to dt. From here we have to put the value of dr, that is dr is equal to dt upon 2r here, that is 0 to pi by 2 and 0 to infinity. Here putting r square is t, that is e to the power minus t, r is already present, and putting the value of dr, that is dt upon 2r and d theta is already present here. R to r is cancelled out, that is integration of 0 to pi by 2 and 0 to infinity, that is 1 by 2 is common out, that is 1 by 2 here and e to the power minus t dt and d theta. On integration with respect to t, that is 1 by 2 is already present, 0 to pi by 2 and e to the power minus t is e की power minus t and on differentiation of minus t is minus of 1, on dividing putting limit, that is 0 to infinity d theta. D theta, that is 1 by 2 limit 0 to pi by 2. From here, that is minus 1 is common out, that is minus of 1 by 2. When putting upper limit e to the power minus infinity, e to the power minus infinity minus of e to the power 0 on putting lower limits, that is d theta, that is minus of 1 by 2 integration 0 to pi by 2, and e to the power minus infinity is 0, so putting here 0 minus 1 d theta, that is minus of minus 1 by 2 integration 0 to pi by 2 and minus of d theta, that is minus minus is plus 1 by 2 0 to pi by 2 d theta on integration of d theta, that is theta, that is 1 by 2 putting the limit 0 to pi by 2, that is 1 by 2 on applying upper limit, that is pi by 2. This is the value of pi by 4. Here is the value of integral is 0 to infinity and 0 to infinity e to the power minus of x square plus y square dx dy is pi by 4. Then we have to show that e to 0 to infinity e की power minus x square dx is equal to root pi by 2. Let p is equal to 0 to infinity e to the power minus x square dx, and also p is equal to 0 to infinity e to the power minus y square dy. This is equation 1 and this is equation 2. On multiplying equation 1 and 2, we get, that is p square is equal to 0 to infinity e की power minus of x square dx into 0 to infinity e की power minus y square dy. Then from here, that is 0 to infinity e to the power minus, taking common, that is x square plus y square and dx dy. We have to find the value of 0 to infinity in given integral. Here, from here 0 to infinity and 0 to infinity e की power minus of x square plus y square dx dy is pi by 4. So putting here, then p square is equal to pi by 4, then p is equal to root pi by 2, and let p is equal to 0 to infinity e की power minus x square dx, putting here, that is in place of p, that is 0 to infinity e की power minus x square dx is equal to root pi by 2. This is the required solution of the given integral. Thank you, class.